All right, this is a video to help you with Lesson 1-6 homework. I've chosen about half of the problems on your assignment, so I hope this helps you, if you need it, to go ahead and answer the other problems in this assignment. So let's get started. The first block of problems, you've got 6 altogether. I've chosen 3 of those. And the directions are first to name each polygon by number of sides. So let's just go ahead and do that first for number 12. 1, 2, 3, 4, 5, 6, 7 sides. And we know that a 7-sided polygon is called a heptagon. All right, and then the next part, answer part B, is to classify it as convex or concave. All right. And so you can kind of think of this originally, if you're struggling with convex, concave, just think about this originally as existing in its entirety, kind of like this. You know, we would have a shape, you know, kind of like this. And what we're looking at in your textbook is a shape where it is caved in certain areas. If you took this original shape, that would be a polygon. You notice that we have intersecting segment lines that create points on the interior of that shape. And so this is called concave. So if you can do an outline all around this shape, it might make it easier. Maybe you don't need to do this, but a true polygon should be enclosed all the way around on the outside, like number 16, for example. That would be convex. All right, so we've taken care of the number of sides. We've taken care of convex versus concave. And now let's do regular or irregular. Well, it is concave, so it cannot be regular. And so we're going to call this irregular. And there's our answer for number 12. All right, so for number 15, let's count the number of sides. So we have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. All right, so remember an 11-sided polygon is called a hendecagon. Hen is the Greek for 1. If you didn't see my lesson video, probably mentioned this in class, but the way the Greeks did 11 and 12 is, you notice decagon. Deca means 10. Gon is just the suffix for angles. So this is a 10-sided figure, and they did 11 by just doing one more. So it's hen is 1, so 1 more than 10 is 11. And so we've classified it by the number of sides. Is it convex or concave? Well, again, just think of this, if you were to picture this in its entirety, you know, maybe some shape like this, you can see where we have angles that appear, we have points that appear, the intersection of 2 lines that are on the interior. So for this to be a convex polygon, then this should be enclosed along the outside, but it's not, so this is also going to be concave. And once again, we have 3 sides that are congruent. Notice the markings, but to be regular, first of all, it has to be convex. And this one obviously is not, so this is going to be irregular. All right, so that's 12 and 15. And then we'll do number 16. Now 16 This is a 1, 2, 3, 4, 5-sided polygon, which is a pentagon. It is convex because we don't have any intersecting lines, any points on the interior. Okay, so that would look more like this, where these would come in like this and intersect. All right, that would make it concave. But this is going to be convex. And let's see, we're told by the little line markings that the sides are congruent. And by these curves around the angles, we're told that the angles are all the same. The angles are congruent. So that's the definition of regular. Okay, that takes care of 3 of your first 6. And let's move on to some others on numbers, starting with number 17 and going through number 22. Your directions are find the perimeter or circumference, if it's a circle, and area of each figure. And we're going to do these in decimal form, rounded to the nearest tenth. So the perimeter first, we know that this length is 2.8. So the perimeter for, this is a rectangle, we do 2 times the length plus 2 times the height. And of course, the height has to be the same on both sides. And so we can grab our calculator and calculate this number, and again, round it to the nearest tenth. So I'm doing that on my calculator. And it looks like the perimeter is going to be 7.8 meters. Don't forget to include the unit of measurement. And then the area of a rectangle is length times width. So that's going to be 2.8 times 1.1. And that is 3.08 in the calculator, but again, we're going to round to the nearest tenth, so it's going to be 3.1. And don't forget, area is always in square units. So the area in this case is going to be 3.1 meters squared, or square meters. All right, number 18, of course, is a circle. So to get the perimeter of a circle, it's called the circumference, actually. We use the formula pi times d if we know the diameter. If you only knew the radius, then you could use 2 pi r. Just want you to see both of those formulas. So we're going to do, since we're given the diameter, we're going to do pi times the diameter, which is 8, of course, and round it. So go to your calculator and use the pi button again, like we talked about earlier. So the circumference is going to be, to the nearest tenth, would be 25.1, and that's that's in inches, of course, so that'll be the answer to circumference. And now we do the area. And for circles, the area is found by doing pi times radius squared. All right, so the radius is half the diameter, so that makes 4. So we're going to do pi times 4 squared, rounded. All right, so back to your calculator. Pi times 16. And that's 50.3 rounded to the nearest tenth. And once again, just a reminder, that's in square inches. All right, and then I've got one more for you. We'll just do one example of, we did a rectangle, we did a circle, now let's do a triangle. So for a perimeter, we just add the sides, the 2 legs and the hypotenuse. So we'll do 16 plus 12 plus 5. It's 33 feet. And then the area of a triangle is 1/2 times base times height. So the base of this triangle that we're looking for is 5 feet. And the height, you got to be careful. The height is the true vertical height. Okay, so when you're calculating height, it's got to be a straight up and down vertical line. The line here that forms this right angle, it's the 8 feet line, the one that is perpendicular to the base. So not the 12. So 1/2 times the base times the height. And so that is going to be 20 square feet. Okay, those are your answers for 3 of those 6 problems. And now let's move down to this word problem number 24. Miss Bell decorates her gazebo with colored lights. The base of the gazebo is a circle. All right, so let's just get a little visual here. It's a circle with a diameter of 12 feet. So this whole length here, diameter of 12 feet. Using the same set of lights, she's going to decorate the sides of her garden shed, which is square. All right, so it's got a square base. So what this is saying is whatever the perimeter or circumference, the same circumference of this circle will be used, we'll use those same length or the same length to help us with the perimeter of this square. Okay, so we have to figure out, well, what is the perimeter here? And then we're going to use that same number over here, and then we'll have to divide to find out what the length of the sides, what is the maximum side length is really the question that we're going to answer. All right, so first let's find out what the perimeter is if she decorates the perimeter of this gazebo, which is a circle. That's called circumference. And that's pi times diameter. So let's find out what that number is. Pi times 12. That's 37.7 rounded feet. Okay, so what this is saying is using the same length of lights. All right, notice that. So we're just going to jump over here, and we're going to use that same length overall. We have 37.7 feet of lights, and we know that this is a square, which means all the sides are the same. So what is the length, the maximum side length of the shed that we can have if we use this overall length of lights? So pretty easy. We just divide 37.7 by 4 since it's a square. And we get about 9.42, 9.43. Since we've been rounding to the nearest tenth, we'll just say about 9.4 feet. Okay, and I've got one more, and this, or two more actually. This is taken from the last block of 4 problems, and you'll have graph paper for this. So the directions say to graph each figure with the given vertices and identify the figure. So let's just go ahead and do that first. -3, -3, that's point J. 3, 2, point K. And then 3, -3 is point L. And it's pretty obvious that we are dealing with a triangle, so I'm just going to get my line draw tool ready. I want to do some straight lines here, if I can. So we'll disconnect these points. Oh. If I tried to do it freehand, it will be really crooked, so do it straight. Okay, so there's our shape, and now we're supposed to identify the figure. All right, so it's a triangle. All right, find the perimeter and the area. All right, so to find the perimeter, we have to know the lengths of the sides, and we also use those numbers to find area. So let's just go ahead and do a little work here. To find the length of the hypotenuse, that's the distance between the segment of the points JK. It's really the length of segment JK. All right, and then we'll do the same thing for KL and JL. Okay, and so this is going to involve our distance formula. So JK, if we find the distance, it's the difference between the x's squared added to the difference between the y's squared. And just do a little work here. So this is going to be, let's come over here. I didn't leave a lot of room. This is going to be -6 squared, which is 36, and -5 squared, which is 25. So that's going to be the square root of 61. And that is rounded at 7.8 units. We don't really have to worry about actual units here. All right, now let's find KL. And KL, the distance, it's the square root of the difference between the x's plus the difference between the y's. And of course, that's going to be 0 squared, which is 0. So this is 2 minus -3. You could probably actually just count those. So that's 5 squared, which is 25, and the square root of that is 5. So this is JK, this is KL, and now we'll do JL. All right, so for JL, it's the difference between the x's plus the difference between the y's. Now this time it's going to be 0. So if these 2 points are on the same horizontal or vertical line, it's really just a matter of finding the difference between either the x coordinate or the y coordinate. So I jumped into the distance formula. You can see it in action, but it's easy enough just to count those. All right, so we did the difference between the x's. All right, so that's going to be -6 squared, which is 36, and the square root of 36 is 6. All right, so we can identify now the side lengths at 7.8. This is 5, this is 6. So we add those together to get our perimeter. And we got 18.8 units for the perimeter. And now let's find the area. So that's 1/2 times base, which is 6, times height, which is 5. And that you can probably see that's 1/2 of 30, which is 15 units squared. Okay, last one. Let's plot t. That's -2, 3. And u is 1, 6. V is 5, 2. and W is 2, -1. And I'll use my line draw tool again to see if I can connect these with straight lines. Okay, pretty good. Okay, so let's name this. Identify is the technical word. So this is a quadrilateral. And if the two sides opposite each other are the same length, then we could go one step further. We could say it's a rectangle, but you can just go with the fact that it's a four-sided polygon means that it's a quadrilateral. And now let's see, to get our perimeter and our area, we're going to need to know the side lengths. So let's do the length of TU. Let's do my work over here. So TU has a length of difference between the x's. Get a lot of good practice with this distance formula. Difference between the y's. So -3 squared is 9, plus, again, -3 squared, which is 9. That's a square root of 18. And we ran into that earlier. That is 4.2 rounded. All right, and then this distance UV. Let's find out what that distance is. 1 minus 5 quantity squared. 6 minus 2 quantity squared. So this is -4 squared, which is 16, plus 4 squared, which is also 16. That's a square root of 32. And rounded, that is 5.6. Maybe 5.7. I've got a calculator that the display is messed up, so I can't tell if that second number, yeah, it looks like a 5, so I'm going to change this to 5.7. I'm using a cracked display. Okay, so just to save time, this video is getting kind of lengthy. This is a rectangle, so TU and VW are the same. UV and TW are the same. So we'll use those numbers to get our perimeter. So perimeter is 2 times 4.2 plus 2 times 5.7. And so we'll go to our calculator. And that looks like 19.8 is our perimeter. And then area is length times width. And so we just multiply these numbers together. 4.2 times 5.7. And let's see what that number is. 4.2, length times width. And that becomes 23.9 if we're rounding to the nearest tenth. Okay, so that's our complete answer. We classified it. We did the perimeter, and we did the area, and I left off squared, so that should be units squared. And that same thing for 26. This is a triangle, here's the perimeter, and then the area in units squared. Okay, well, hope that helps. If not, if you need further help, contact me. Come to academic support. You can always send me an email, but otherwise, I look forward to seeing you next time.